two statements of second law of thermodynamics. The first statement is called Kelvin-Planck Statement, and according to the Kelvin-Planck Statement, it is impossible to construct an engine or device which produces 100% efficiency. So according to this statement, it is impossible to construct an engine or device which gives 100% output. Here we are considering two sketches. The first sketch, it will represent that this device is not practically possible. So here we are using two words, source and sink. Source means which reservoir it is available at high temperature, it is called source, and which reservoir it will be available at lower temperature, it is called sink. So for example, whenever we are considering two body, for example, this is body A and this is body B. The temperature of the body A is 500 degrees Celsius and the temperature of the body B is 25 degrees Celsius. So this body, it is available at high temperature, means it is available at 500 degrees Celsius. So this is my source. This body is available at lower temperature, means it is available at 25 degrees Celsius. So as compared to this body, the temperature of this body is less. So this is my sink. So heat is always transferred from high body temperature to low body temperature. Suppose it is electrical energy, so it will be transferred from high voltage to low voltage. Suppose it is a pressure, then it will be transferred from high pressure to low pressure. Means in short, energy is always transferred from high grade to low grade. So here we are considering the example of heat engine. We have already discussed what is heat engine. Heat engine is a device in which chemical energy of fuel, it will be converted into heat energy. It is called heat engine. There are basically two types of heat engine, IC engine and AC engine. In previous lecture we have already discussed the classification of IC engine, 2-stroke, 4-stroke. So here you can see that the heat will be transferred from high body temperature to lower body temperature. So here you can see that it is called source, which is available at high temperature T1. It is our sink, which is available at low temperature. So heat will be transferred, 10 kilojoule of heat will be transferred from higher body temperature to lower body temperature. So in that case, there is no any heat loss. But practically this type of device, it is not possible, because in each and every device some losses are there. For example, whenever we take the example of boiler, so it is a one type of EC engine. So there are number of losses in case of a boiler. For example, whenever we supplied the coal for the combustion, so at that time in a coal already some moisture content will be present. So 1 to 2% of energy, it is wasted or it is required to remove the moisture content from the coal. So it is a heat loss to remove the moisture content. Another case, for example, heat carried by exhaust gases through the chimney. This is also the wastage of heat. Means it is a wastage of heat energy. Same like as in IC engine in our bike. IC engine means internal combustion engine. So in our bike, truck, whatever we are using engine, it is a IC engine. So in that engine, there are number of losses. Same like as heat carried by exhaust gases in silencer, it is also a heat loss. You all observe that the radiator is mounted on front side of the car. So this radiator is also reject the heat, and some of the losses in friction. Everywhere some losses are there. Some of the losses we cannot calculate it, same like as in pumping loss in IC engine. So this type of device is practically not possible, in which device we achieved 100% output. Here we supplied the 10 kilojoule of heat energy. So output is 10 kilojoule, means the efficiency of this engine is 100%. But practically this type of engine is not possible. So this second schematic diagram, it will represent, here you can see that 10 kilojoule of heat energy is supplied to engine. Out of this 10 kilojoule energy, 2 kilojoule of energy wastage to sink, means at lower body temperature. This 2 kilojoule of energy wastage at lower body temperature whenever the heat will transfer from higher to lower. So my net output is input minus loss, Q1 minus Q2. So my Q1 is 10 kilojoule, my Q2 is 2 kilojoule. So my net output is 8 kilojoule. Practically this type of heat engine is possible. This device is not possible. It will violate the second law of thermodynamics, means it will give the 100% efficiency, but practically there is no any device or engine is possible to give 100% output or 100% efficiency. So here in second case, in second schematic diagram, efficiency equal to output upon input, my output is 8 kilojoule out of 10. So my total input is 10 kilojoule multiplied by 100 equal to 80% of efficiency, means 20% are losses, 20% of losses in engine. So according to the Kelvin-Planck statement, it is impossible to construct an engine or device which produces 100% efficiency, or the total heat is not converted into work. Some losses are there in the device, means it will reduce the efficiency of the engine. The second statement is called Clausius Statement, and according to the Clausius Statement, it is impossible to transfer the heat from lower body temperature to higher body temperature without giving any external work. Let us take one example. Here we are considering the example of hot cup of tea. Hot cup of tea. It is available at 45 degree Celsius. So naturally, this hot cup of tea, it will reject the heat to atmosphere. For example, my atmospheric temperature is 25 degree Celsius. So naturally heat is transferred from higher to lower. But practically, it is not transferred from lower to higher without giving any external work. For example, this hot cup of tea, it will reject the heat to atmosphere, so the temperature of the hot cup of tea, it is continuously decreases. And after some time, the temperature of the hot cup of tea and the temperature of the air, it should become same. In reverse process, the same cup, it will not receive the heat from air. It is only possible whenever we put this cup on stove or any heat equipment device, then and then it is possible to achieve the same temperature. To understand the Clausius statement, here we are considering the schematic diagram. This first schematic diagram, it will represent the heat will transfer from lower body temperature. Lower body temperature means cold environment. So in case of a refrigerator, what is my cold environment? So inside the cabinet of refrigerator, this is my cold environment condition. What is hot environment? Hot environment is outside of the refrigerator, atmospheric air. This is my hot environment condition. So heat will be transferred from lower to higher, means this refrigerator, it will receive the heat from inside the cabinet of refrigerator and it will reject heat to atmosphere without giving any external work. It is not possible. It is not possible. Whenever you switch on the refrigerator, then and then it is possible to transfer the heat, means some input energy or some work done is required to transfer the heat from lower body to higher body. Without work done, it is impossible. Naturally, heat is always transferred from higher to lower, but lower to higher, naturally not possible. But whenever we want to transfer the heat from lower body temperature to higher body temperature, at that time some input energy is required on the compressor. Then and then it is possible to transfer the heat from lower body temperature to higher body temperature. So this is not possible without giving any external work. So in another schematic diagram, here you can see that the heat will transfer from cold environment condition, means the inside the cabinet of refrigerator, to hot environment, means warm environment condition outside the refrigerator. So it is possible through work done on compressor. So here you can see that here we supply here we supply the energy to compressor equal to 4 kilojoule. Then it is possible to transfer the heat from QL, means cold environment condition, to hot environment condition. So this is possible only in which case, whenever we supply the work on the system. It is only possible through work done on the system. Here we are considering instead of efficiency. Efficiency means output upon input, and COP is also output upon input. Then why we are considering COP? So in case of a refrigerator, the performance of the refrigerator, it will be measured by COP, coefficient of performance. Why we are not considering efficiency? Because efficiency is always less than 1, and the value of the COP, it might be possible, it may be more than 1, 2, 3. So here we are considering COP, coefficient of performance. It is also output upon input. What is the output of refrigerator? Output means how much amount of cooling will be produced. It is called refrigerating effect. Amount of cooling produced, it is called refrigerating effect. And input means heat supplied, work done on the system. This is my input for the refrigerator. So WC, it is an input for refrigerator. So COP means output upon input. Output of refrigerator means how much amount of cooling will be produced. It is called RE, refrigerating effect. Input means work done on the compressor. It is called WC. So in our case, refrigerating effect means it will be received from cold environment, means the temperature of the cold environment again, means it will receive the heat from cold environment, and it will reject heat to hot environment, means it will receive the heat from inside the cabinet of refrigerator, and this refrigerator, it will reject the heat through condenser to atmosphere. Means here the heat will transfer from lower body temperature to higher body temperature by giving some external work on compressor. So this is a net output equal to 4 kilojoule. So here you can see that my QL, refrigerating effect, means QL equal to 8. Work done on the system equal to 4. So the COP of the system is 2. So practically it is possible through work done on the system. So this is the fundamental of second law of thermodynamics.